Hello students, today I will discuss about the hashing method. So in different question paper, as it's a very mathematical based thing, you may find different problems regarding this concept. Now the first of all, what is this and why it is there? You may consider hashing is a method, it's one of the efficient searching method. Now why it is efficient searching method? So if you can listen to the or remember the thing we have discussed in the previous lecture, there is discussed two searching algorithm. One of them is linear search and another one of them is binary search. So in case of binary search, you can think about that it's kind of the way the division and everything is being performed. It's basically tree like concept. Fine, in one side again divide. So we have seen that one of the thing is that if I want to search something in single array, that is basically big O of n. Fine, big O of order of n size must be there. Not clear. If I want to search something that may present in any position of the array, and in that case I need to traverse from beginning to the end. Fine. Now if I am going that there is a sorted list and I can use some other algorithm, then there is the binary search. Now all the complexity value, that is the time complexity value that you may come across, log n is the smallest one. Fine, but for a huge list that is a problem again. So what we can do, we can have something that is basically your smaller than that. So as for that demand, that you need to go through that what I can say, you need to go through something that you want that address must be in such a way present all the data in some address that must be fetched in very little time. So if you consider anything less than the log n, that must be the only option is the constant time. So constant time is represented by the 1. Yes, we can think it in this way, that it may obtain, the data may be obtained in a single step, but 1 doesn't signify that this is single step, rather it is actually signifying constant time. Fine. Now this is the purpose of the hashing. Now how these things can be done? There is basically one hash table, one particular data structure is being used and which is called hash table. Fine, means it's a tabular format where it's like array, contiguous location in the memory. It's a data structure and each and individual position are identified by its index position. The default indexing start with the 0. Now values are mapped to this position as per some requirement, as per some calculation. Now calculation is based on some mathematical formula, or that is called basically the hash function, and the value that you want to keep and that you want to search after some time, that is basically your key value. Fine. So that is the thing that you need to understand, or that is the thing we are going to study, that there will be some set of key values and you need to insert them in such a way so that when you want to retrieve them, it will take almost very less time, or most of the time it will take basically the constant time. That is important, right? So that is the thing that we will go to learn. And not only this, that it will be a normal mathematical problem, it has one huge application of that. So now So where is the application area? So it can be applied to implement various abstract data type based dictionary. Many compilers use the hash table to keep the track of declared variable. There are some spelling checker, fine, and enter dictionary can be pre-hashed and words can be checked in constant time. So these are means for a huge list this may be beneficial. That is the main point. So these are the thing we are supposed to discuss. So without wasting much time, let's go to the entire thing. Now the thing is, few things I need to remember, that to achieve a constant time, what is requirement? I need to have one array. Fine, I need to have one array. I should not have any kind of linked list presentation. The reason is I want to search a kth element in an array in constant time. But in case of linked list, that is not possible, because you need to go to that particular node, then you will get, again it will take more time. So now we are going to design basically a container used to hold a given set of item k, which is called keys. Then there will be one hash function which will take the key and will do some mathematical operation, and one value will be returned, and that value is the hash code, and the keys will be mapped in the m, that is in the area where you are supposed to keep in the list as per those hash code. Fine, that is the main purpose. So throughout the procedure we will learn that kind of approach. Now few considerations are there, that we expect the size of the set of the keys will be relatively large as comparison to the number of items stored in the container M. In other words, the container is significantly less than k. Fine. So that we use an array of size M to contain items. So these are the preliminary considerations whenever we are going to discuss any kind of thing. So the basic thing is mathematically that there is a function k is mapped to 0 to m minus 1, and this function will map or transpose the set key values to be stored in the container subscripts indexes in an array of length m. This function is called the hash function. Now there are various methods to do the hashing. The first thing is the division method. This is very preliminary method. K is the key value that we have already discussed. Hk will get some value, and this is the hashing function, and hk you may consider that is basically the index value where you are supposed to put the result. Fine. So hk is that hk equals to k mod m. Fine. M is your container value. Now what is the criteria? See, whenever you are designing any hash function, we will need to consider few points, that there are few properties are there for any hash function. One is low cost. Low cost means there is no price involved, there is time requirement. It should be less time consuming. Fine, the function should be very small. Second is determinism, that same hash value must be generated for a given input value. Fine, but obviously if sometime different external variables are involved, that is not possible. And next most important is uniformity, that throughout the container, throughout the space, the keys must be distributed in open manner, means total container must be filled up properly. So these are the criteria are there. Fine. Now so we are in the division method. Now division method, you can see that it's a very simple, just the key values is divided by the size of the container or one m. Fine. Now what is the criteria? to get a better result? To get a better result, m should be a prime number. Fine. And it should not be a number which is closer to the value of 2 to the power k. These two are criteria. Fine. So just I have taken one example. Suppose one number is 1234, 1234 and m is a 97, then is 70. Fine. So there will be one set as m is 97, so you have the space from 0 to 96, all the locations are available and you can store this 1234, 1234, this value to that particular location. Now, but the problem in that method is that whenever you are going to allocate them, it may take consecutive positions. That's sometimes good, sometimes not so good. So next we will start the next method, that is the multiplication method. So what we are supposed to do with the multiplication method? In case of multiplication method, these are the steps. First, choose a constant a such that a must be a fractional value, positive fractional value in between 0 to 1. Fine. Second is what? Second is, in the second step, multiply the k with that a. Fine. Then extract the fractional part. Extract the fractional part of the multiplication value, multiplied value. Fine. Extract the fractional part of the k multiplied by a from that part. And in the fourth step, what you need to do? Multiply the result of step 3, that is the fractional part, by the size of hash table. Now for the consideration, there is a famous mathematician and who has written all the volumes of the computer science, the Knuth. He has suggested that the a should be taken as 0106180339887. Even if you are taking up to 0618033, it will work. So what you need to do now, and the hash function value is calculated as this floor value. Floor means if I consider 3.36, then floor value is the lower value. Fine. And if I go for the higher value, means ceiling value, the value will be something, the constant value which is higher than the 3.36. Now, it will take the floor value or the normal value ka mod 1, basically the fractional part. Now, the given value is 1, 2, 3, 4, 5 and one hash table size, that is the container size, is 1000. So, and we are taking the a up to 3, 3. Then what will happen? First you are multiplying 1, 2, 3, 4, 5 with that a. So you will get the result as 7629.617385. Fine. So you need to take the fractional part. That means the right side part after the part after the fractional point. So that part is 617385. Fine. Take that part and then multiply it with the 1000. So what are the steps? I am just repeating. 1, 2, 3, 4, 5. Multiply it with the a. You will get one value 7629.617385. 0.617385. You need to take only the fractional part. So you are taking 0.617385. Fine. Then you need to multiply it with the size of the hash table, which is m. Fine. So multiply it and you will get 617. So your containers is having the location from 0 to 999 and you are admitting this or you are inserting this to the location 617. So this is about your multiplication method. The next method, various methods exist. This is I am discussing one by one. Next method is mid-square method. Another new method. Now, what we do in the mid-square method? Square the value. key, means you need to perform a k square. Fine. Then extract the middle r digits. Middle r digits. Now how you can decide the r? That depends on the container size. If the container size is 100, then your r will vary from 0 to 99. So your r will be now 2 digits. If the container size is 1000, then the r will be of 0 to and the range will be 0 to 99,999. So then the r size will be 3. You need to take middle 3 digit. Now again, whenever you are taking the middle digit, see, from a number, it may not be possible to decide which 2 or which 3 digits are exactly in the middle position. So what is better? Better is that you should make a note that every time, see here, the first is 1522756 and second was is 31832164. 31832164. Now in each case you need to take the digits almost in the same position. Fine. Means when you are taking the middle, you need to consider that how or in which side you are considering the middle one. Fine. So this way here it's taken as 27 and 21. See, in each case you are leaving 2 digits in the right side. Fine. So this way means if n number of elements are given as key value, you need to take all the mid position digits in such a way. So this is another method. Next method is folding method. In case of folding method, the purpose is to divide the key value into number of parts, and each part except the last should contain same number of digits, and then you add individual number of digits. Now if you have decided that part size will be 2, then if after the addition you are getting some carry, just discard it. Now here is one example. Some keys are there: 5678, 321 and 34567. Fine. So we'll start dividing. So 5678, 321, 34567. Okay. Do the summation. 134, 33, 97. 33 and 97, they are of 2 digits after summation, but 134 is having 3 digits, so we are ignoring the carry and we are taking the 34 only. So this is another method. So in the question paper it might be told to you that this is, you need to use this procedure. But hashing is not so easy all the time. There is a high chance that there will be a collision. Why? The reason is k is greater than, much greater than the m. So there is a high chance in the same location more than one value try to enter. So definitely there will be a collision. So should the system, or should you as a programmer, should allow the collision? Definitely no. So what you need to do? You need to learn the hashing in according to some collision mechanism. Fine. In accordance with some collision mechanism. So here some collision resolution process. So linear probing method, just double hashing method, quadratic probing method, different chaining methods. So here we will discuss only some of the basics, cause we are not studying is this for some seminar or all those things. Just we need to know how all these things are being done. Most, if the questions come from the hashing method, these will come from this probing method mainly. Chaining methods are not so popular in case of this kind of exams. Now collision means whenever two items want to enter in the same position, want to acquire the same area, then the collision will occur. So you need to resolve. Resolve means you need to offer some better position for that particular data. Some better position for that particular data. So the first method is linear probing method. Okay. Now, in case of linear probing method, we use the very basic method. Now, all the methods that I have discussed, because of the simplicity, the only division method is very much popular. Only division method is very much popular. Fine. So, whatever the probing method we will discuss, linear, quadratic, double hashing, the base is for the hash part, hash function is the division method because of its simplicity. Fine. Or the low cost, whatever you may tell it, and it also assure the uniformity. So it has almost all the properties to be a good hash function. So in case of linear probing method, the idea is that there are m nodes, k number of keys are there, and k are being divided by some positive integer m, which is officially a prime number. Now you have to assign it to some position of the m. The idea is that if the desired location, that the value that you are getting after doing the k mod m, if that location is not vacant, then what you will do? Then you need to do one thing. You need to search next free position. If the desired location is not free, then you need to continue in forward way, that which is the next free location is available. Where is the next free location is available. So in general, when we do the problem solving, or if we get the snapshot of the problem, you may observe that in the hash table, many of the positions initially marked with some sentinel value, that is, you may mean system or the problem giver may give it as -1. So -1 means it's vacant. Fine. So you may get snapshot of the problem in such a way. So now what we need to do, this is my basic operation, k mod m, that is the thing I am supposed to do. But with the linear probing, these are the concept that I have discussed. With the linear probing, you have to do it in this way. Hk equals to h prime k plus I. What is the value of the I? I will basically move. I will basically move from 0 to 1, means 0 to m minus 1, 0 to m minus 1 continuously. Fine. So I will continuously move from 0 to m minus 1. Okay. If collision occurs, otherwise it may just evaluate, and if the place is available, it will be assigned to that. Now for example, this one. See, it's one example. There are few of the keys, 32, 53, 22, 92, 17, 34, 24, 37, 56, and so on. And the table size is taken as m. So the container size is m. So what you need to do, just take your pen and paper. Otherwise, whatever I am discussing, it will be only on my mind. It won't help you. Believe me, it won't going to help you. So first is 32. Okay. So your key value is 32. You need to do what? H prime k. H prime k is what? Key mod m. Okay, you do 32 mod m. 32 mod m. So it will give you 2. Okay. Plus, what will be the initial value of the I? The value of the I, initial value should be 0. Means when nothing is happening, it will always be taken as 0. Once the collision will occur, then it will start from 1. Right? So it is initially 0. So if you do it, 2 plus 0 mod m. So as per the integer division, the result will be 2 only. So see, 32 is allocated to the position 2. Okay, that is very good. Similarly for 53, no collision, it will be assigned to the third position. Next, the same value, 22. What will happen for that? 22 again it will generate the initial reminder as 2 with I as 0, but 2, the cell number 2 is already occupied. So what I can do? I can do 2 plus 1 by mod 10, 3. No, that is not available. I equals to 2. 2 plus 2 means 2 is the h prime k is value. So 2 plus 2, it will be now 4. 4 mod 10. 4 is vacant. So you can assign it to that particular position. So please take your pen and paper and try to understand this. Just try to solve it. Just try to solve it. So this way all the values need to be calculated. So for example, when you are in the 92 or in the 34, again this is for 2, not happening, not free space, come to the 5, 14 and this way. Now this way it's a very simple thing, just based on the formula that I have used in the previous slide. You have to allocate it and you will get all the facility of the hashing, that you can search the item in very less time. Now there is a problem. Whenever we are doing this, there is a problem. What is the problem? That whenever you are searching the space, even in the previous one, what will happen? Even in the searching space, that will be, and the problem is that for a single search, if those positions are not available, then what will happen? Then they need to search one by one. So it's a clustering kind of sort. Fine. They are forming the clusters. When one position is not vacant, they are going in this way and they are forming cluster. Means they are trying to point, all of them are trying to point to single position, and that's creating the problem. So that is the problem. Fine. So there is some other method. One of them is quadratic probing method. Quadratic probing method is attempt to keep, just try to prevent the cluster forming. So let us just directly look into it. Rest of the information are same. This is the basic division method. Again for hk function, that is the normal hash function, we are going to use this, and this is this. Here one hk is used, c1 c2 2 constant is used, and one I and I square is used. Then the entire thing supposed to be divided by the mod. C1 C2, these two are non-zero constant. I will move from 0 to m minus 1, and hk again k mod m. Now just let us look at the example, and you should try it by yourself. If you have any problem, you may contact me personally or in the chat. I can answer you that. Just I am telling you the first step. So for the first element, that is 10. Fine. So for the 10, what you need to do? K mod 10. So 10 mod 10 plus I initially is 0. Unless until there is a collision, I will be considered as 0. So this will be C1 into 0. Suppose C1 is 2 and C2 is 3. Then C1 into 0, C2 is also 0. Then what will happen? Then the entire thing, that 0 0 0, all the thing is 0. Now if I mod this again, I will get 0 again. So in each case, what will happen? In each case, the result is 0 for the 10. So as 10 is supposed to have the hash value as 0, so it will be mapped to 0 only, 0th index only. Done. So 10 is there. Fine. Let's go for the next value, 15. So similarly for the 15, the remainder will be calculated, that is the hash value will be calculated as 5. So place the 15 in the 5th position of your array, that is the container. Next for 16, yeah, again in the similar way you can get its the proper position. The problem will start with 20. So if I go with the 20, what will happen? 20 mod 10, 0, fine. Then C1 into 0, C2 into 0 square or 0. So this is basically again 0, returning the 0, but that is not possible. So then what you need to do? You need to start the collision resolving. The collision occurs and then you need to go for the resolving the collision. So how you can do that? You need to start it in this way. 0, that is 20 mod 0, fine, plus C1 into 1. What is C1 here given? These two value will be definitely given. C1 into 1 plus 3 into 1 square, because I is 1, I have considered I as 1. So this will give you 0 plus 1 plus 3, 4, 4 mod 10. So the result is 4. So now the 20 will be placed in the 4. Fine. So this way, similarly for 30, again you need to calculate. So for 30, you will definitely, for this you may not get the proper position like as 20 in the first step. You may need to proceed for more step, and this way you can do. So this is the procedure. Once the collision occurs, you again start the I with 1. If 1 is vacant, you allocate it there. If 1 is not vacant, then go for that I equals to 2, and so on. You have the option to go it from 0 to m minus 1. So by default, when first time we are allocating, we are trying to allocate the value, we take the 0. So this way you need to do. But again, this will generate one secondary clustering problem. Definitely, a same type of value like to be clustered in same area. Whenever the collision occur and you are using the same kind of pattern, it will suppose to try to cluster in same point. Again, so to solve this, there is another method, double hashing. So double hash function is used here. Double hash function, fine. Just to try to solve the problem of this clustering. Just let us look at the formula again. This is h1k. There will be two hash function. The basic of the hash function is k mod m. Fine. So in case of k mod m prime h2k, this m value must be smaller than that. That is one criteria. Fine. That smaller than that means m prime may be m minus 1, maybe m minus 2. A little bit smaller than that. And this is the formula by which you need to now need to calculate the value, and you need to do the rest of the calculation. So suppose consider these values 72, 37, 36, 24, all these values are given. h1k is k mod 10 and h2k is k mod 8. So just start the calculation, the normal arithmetic calculation. By this time you have understood. I am giving here this problem. Again, for your trial, if you find any problem, you ask me, I will clarify your doubt. I am not giving the entire solution here itself. I may give you solution the later. Now, another thing is, in each of the process, every time the clustering problem more or less will exist. Double hashing solving a huge amount of that problem in huge extent, but still some problem exists. So there is another concept of chaining, which is based on basically the linked list. Chaining method is based on the linked list concept. What is being done there? See, whenever you are getting the same reminder for different value, that is same hash code for different value that are supposed to be mapped in the same index position, but that is not available, then you are using this probing, linear probing, quadratic probing. So it involves huge amount of calculation. Fine. So these are not simple. Fine. These are not actually cost effective. These are huge amount of things. So that's a time consuming for a system, for a huge list, that is time consuming. So there is another proposal that for each thing, it's look like the bucket shot thing, that there is a 0, 1, this for each index value, it's a starting node, and for each index they maintain a list. So maybe for this kind of thing, whenever one, suppose for the first value 30, it's coming here, it will be allocated. When the next value is coming with the 0 as hash code, no probing, nothing is required, just add a node, So this way things may be distributed. Yes, obviously searching time now it's not in the big O of 1, but is big O of not in 1, but it at least in linear order. Because if I go for all those calculation, it may take more time in the calculation. So it depends on the system, what kind of values are going to be used, and over what kind of data set it's going to be used. That is the best thing. But for your purpose, there will be few hash value, there will be some screenshot, you need to find the which one is the proper one, and the procedure will be written, that which particular procedure they are using. Look at the thing, understand the concept and solve the problem. Thank you.